solutions. So we're going to talk about accelerating AI fabrics for storage. So, you know, AI, we put a lot of effort into accelerating it and improving it. GPUs, you know, from the entire stack. And one of the things we find is that slow storage can slow down your AI training times. It'll slow down your inference. Like even with things like RAG, there's a lot of work that's done to deal with the ingest phase, where it's kind of reading the material. And so anything that gets between the kind of the storage and the GPUs is going to slow down the GPUs, and you'd end up with, you know, idle GPUs going on here. And so whether you're talking about any part of AI, fast storage makes a difference. And if you heard Jensen's talk today, he talked about accelerating more than AI, right? There's a lot of stuff where we want to accelerate, you know, the eyeballs off of lots of different applications. And all of them need fast GPUs and fast storage. So what do? We have a technology called SpectrumX that is geared for and optimized around accelerating GPU to GPU traffic. If you guys have heard of, you know, GPU Direct or anything like that, we took a lot of the innovations from our InfiniBand products and we brought it over to Ethernet, and we call it SpectrumX, and that's been going along very well. In fact, Cisco just announced they're supporting SpectrumX, this same technology. But one of the things we said is, well, can we take the same innovations and apply it to accelerating the storage traffic? And so in just a very simple kind of taking that technology over and working with key partners like DDN, we learned that, well, the storage traffic is a little different than the GPU traffic, so we had to do some different tuning. But they were able to kind of validate that they get about 50% improvement in the GPU storage bandwidth, and then also in the face of noisy neighbors, we could see a lot of improvements as well. So if you look at, well, what are the use cases? So everything at NVIDIA is kind of from the viewpoint of the GPUs. So if you look at the traffic pattern from a GPU, and you're doing things like these large read operations, you're loading the models. You know, these are these, you know, billion parameter models, and they take a while to load. And what you end up with is these very large elephant flows, which traditional Ethernet does not handle well. Even the world's best kind of rocky Ethernet has to do a load balancing on a flow-by-flow basis. So anytime you do load balancing on a flow-by-flow basis, you end up with multiple elephant flows landing on the same links, and other links being kind of underutilized. We call that an ECMP collision. So you see a lot of stuff about collisions. And so one of the things we do with SpectrumX is, instead of load balancing on a flow-by-flow, we load balance on a packet-by-packet. And by doing that, we're able to kind of get perfect load balancing across the fabric. Of course, in order to do that, you have to deal with out-of-order packets when they arrive at the other side. And so that's one of the reasons why you have to have our technology in the storage appliances, in the GPU servers, and the switches. It's a full-stack solution. But we can then reorder those packets as we do the kind of RDMA operations. The other thing has to do with congestion. So anytime you're dealing with multiple switches and you've got a scale-out deployment, you have another kind of congestion to deal with that you can't route around, you can't do adaptive routing. It's when you've got multiple GPUs sending data to one storage appliance, or multiple storage appliances are sending data to one GPU server. And this is an in-cast kind of congestion. And again, these are innovations that we brought over for improving GPU traffic, but we were able to kind of improve storage as well. And so there was kind of a third kind of area that weighs in here, and this is around lost links. So every time we have a deployment at scale, there's always a lost link. And the math is, you know, pretty simple, but if you have 100,000 GPUs, well, then, you know, there was some talk about at the keynote today where they're like, well, if you have 100,000 GPUs, you've got like 600,000 optics, right? You have a tremendous number of cables, and there's always one cable down. In fact, there's always multiple cables that have a link problem. And so what that means is a couple things. One is you're never truly non-blocking, right? You always have to route around some blocking issues, even if you have designed it to be non-blocking. The other thing is we find that traditional Ethernet, even with Rocky, is when you lose a link, we see an outsized drop in performance. And a lot of it has to do with not being able to route around these problems. So for example, if you had 100 links and you lost one of those links, you might assume, oh, well, I'll see a 1% drop in performance. The reality is we see a much larger impact in performance and things like that. In fact, so you'll see some kind of things that say, if you see a drop in throughput to the GPU, you're going to see a corresponding drop in AI performance, especially with things like DeepSeek. When you start looking at mixture of experts, it all plays into that model. And so we do a bunch of things to route around problems better with our SpectrumX technology. And then lastly is about visibility. So visibility is important for bringing up these large deployments. So we famously, with the Colossus data center with 100,000 GPUs, we were able to see time to first token in a matter of a few weeks, a handful of weeks, which was a major accomplishment. Instead of years, it was weeks. And the way we did that is we had really good telemetry so that when there was a problem, we could detect it. If there's a problem in the fabric, or we even predict some of the problems in the fabric. But that was all for the GPU fabric with SpectrumX, so that compute fabric. And so what we're doing with SpectrumX for storage, with our partners like DDN, is we give them that visibility into that whole fabric. Instead of the fabric being a black box where they have to kind of say, well, we assume everything's working well, now they can have visibility because DDN's orchestration tools can talk directly to NetQ using an API. So whether you see this window or not, the DDN tools have access and can see, hey, NVIDIA is telling us there's a problem on these links, or maybe there's going to be a problem on these other links, because there's some predictive stuff that goes on as well. So it all comes together to kind of improve performance. And one of the things that we did is we benchmarked this. So we're big on kind of dog fooding our own technology, meaning we tested out, we've got the luxury of having these massive supercomputers to test things out. And so one of the things we did is we have a supercomputer called Israel 1. It's the largest supercomputer in Israel, and it is kind of the proving ground for when we are developing SpectrumX. When we went to deploy Colossus, before we did that, we simulated and emulated and tested everything out on Israel 1 ahead of time. And so, but again, that was all on the GPU fabric. When we started looking at taking the SpectrumX and applying it to storage, we said, well, the perfect proving ground is Israel 1. And so what we did is, if you're familiar with the concept of scalable units, they're kind of Legos, building blocks of an AI data center. And so we have 4 scalable units, and we're very deliberate to say we're going to take 300 of the GPUs, and we're going to do a lot of these storage tests across these scalable units. What that means is it's forcing traffic across the leaf spine environment. It's forcing some of these problems that we're trying to solve. And so, again, from NVIDIA's point of view, everything is like from the GPU. So when we say we did an FIO write benchmark, that means from the GPU, we're writing data to the storage appliance. And so we're sending data, and this is very similar to doing checkpoint operations during a training environment. Then we also did an FIO read benchmark. And this is much more like an ingest phase of like with RAG on the inference side of things. And so what we found is that using the same switches, the same cables, same adapters and everything, and we said, well, let's configure it for Rocky, and that's the gray bars, and what we would consider the world's best implementation of Rocky. Like we used our switches, we used the same IP addresses, the same everything else, and we were able to kind of get a certain level of performance. But without changing the cables or the switches or the adapters, we just said, all right, well, let's turn on the turbo button, right? We'll turn on the SpectrumX features so that we will load balance on a packet by packet basis instead of flow by flow basis. And we'll have all the advanced congestion control. We're able to kind of accelerate the performance by almost 50% when it comes to writes. Now, the other thing we did is you'll see DDN did their own POC, and they went ahead and published a white paper on the results that they got when they tested SpectrumX with their full stack. Where the testing that we did was very much of our low-level FIO benchmark, with DDN, they have the storage expertise to test with their full file system and verify this performs well in the real world. And so they went ahead and published a bunch of other benchmarks that I'm not going to present on their behalf, but they were very good about making it available, putting it on their website, writing a white paper on it, on those results, and a technical blog. And then that corresponded, we also have a technical blog that you guys can look at. And then there was a number of, we have some links here for some other press coverage of this. But yeah, so essentially this is something that we launched just last month. And it's really about taking the innovations that we brought to accelerate compute fabric and bringing in to accelerate the storage fabric. And yeah, so that's, I think, all I have to say about that. Anybody have any questions?
Question over there? Here, I'll let you use the mic so everybody can hear the question.
Hi. So regarding SpectrumX, which earlier today Jensen talked about CPO for SpectrumX.
Yes.
But he says the second half 2026. So are you will you be shipping SpectrumX with just regular transceivers for now until second half 26, or what's the plan?
Yeah, so the today, until that platform comes out, all of our Ethernet switches and SpectrumX will use discrete optics. So you won't have a co-packaged optic option. We will have it for our InfiniBand products. So starting like first half or second half of this year, you'll see the Quantum platform with the co-packaged optics. But yeah, when it comes to Ethernet, it's going to follow on next year.
Any other questions out there? No, David, you must have been that thorough.
Oh, perfect.
All right, how about all this round of applause for you?
All right, thank you guys.